Hello! In this video I'm going to show you how to create this fairly simple generative artwork using Max MSP and Jitter. Now, this artwork is not my own invention or creation. In fact, I have taken this from a P5.js sketch that you can see it behaves in the same way, but it uses JavaScript code instead of a Max MSP Jitter patch. This is the first video in a series I plan to develop over the next weeks and months and maybe years, in which I use the book Generative Design Creative Coding on the Web as the source for adapting certain P5.js sketches into the world of Jitter, or more specifically Max MSP and Jitter. The Generative Design book is an amazing book. This is an actual book that teaches you how to create generative artworks using JavaScript, more specifically using P5.js. Me making these videos are entirely on no level replacements for reading this book. I do recommend buying this book. You can buy it on Kindle, from paperback. I am advertising for it. I can vouch for it. But I do have to say that all of the generative artworks are available on the internet, on their website, as P5.js code. And to me, this is very interesting because I would like to try and recreate almost all of these, because some of these are using actual browser objects like sliders and buttons and knobs. But the other ones I do want to try and recreate on Max MSP. For one thing, this I hopefully will show the capabilities of Max MSP and Jitter for creating generative artworks. And secondly, it's a fantastic chance to learn things about jit.gen, jit.gl mesh, and all kinds of different creative techniques adapted from concepts from P5.js into the world of Max. So again, we are going to start with the simplest one called hello color, 2 rectangles, different colors, reactive to the mouse position. Let's do this. And here in front of me is the classic Max MSP Jitter empty patch. And while the blankness might be intimidating, this is not my starting point this time. I'm going to be using this P5.js sketch as my basis. It's taken from the website Creating Coding in Web, as a book that was published in 2018. And the code itself is open source. It's shared freely on the internet. And if you can read JavaScript well, maybe you can figure out what is going on here by just looking at the code. But I want to figure this out by, well, playing around with this little generative artwork. And what is happening is fairly simple. There are 2 rectangles, or squares, but I'm going to call them rectangles because we might end up changing the aspect ratio down the line. And, well, the size of the inner rectangle is determined by the horizontal position of my mouse. If it's all the way to the left, there's almost nothing, and it grows bigger and bigger the more I go to the right. And if I'm all the way to the right, it completely covers the screen. The vertical position of my mouse, or my cursor, is what determines the color. Notice that both rectangles, the outer and the inner, begin with the same color. They have the same color in the middle, and they end with the same color. However, anything in the middle is different. There is a very simple trick to achieve this. Both rectangles are going through the, let's say, the wheel of color, right? The color circle, or all possible hues. However, they are going in different directions. One is going clockwise and the other one is going counterclockwise. So they begin and end on the same point. The middle point is the same, but otherwise it's different directions, creating interesting complementary and different combinations of colors. So we have to think about detecting mouse position and detecting certain color systems, and we have to see in which ways we can make this possible in a Jitter, maybe a jit.world window. So this can be your starting point. I can create a jit.world, a Jitter world context. I can call this anything I want. I'll just call this gen color, and I can give it the usual attributes of floating set to 1 and FSAA set to also 1. And while, as I've said, there are different ways of tackling this, or tackling this problem of recreating the P5.js sketch in Max MSP, I want to use this as an opportunity to work a bit with jit.gen. I think this is a good opportunity to flex those muscles, because if we don't flex those muscles, we might end up losing them. And how jit.gen is going to work is simple. It is going to receive a jitter matrix, a jit.matrix. This is going to be our empty screen, which will be filled in by the jit.gen code. It is going to have 3 planes, RGB colors, float32 data type, and its size can, or its dimensions can be arbitrary. Let's make it 800 by 600. Now, by default, if I try to visualize this by, I don't know, using jit.p window, and if I send a bang, well, nothing is going to happen. It's going to be completely dark. The same thing will still happen if I use a toggle to turn the jit.world on. Still, this jit matrix is not doing anything. However, ideally, once I'm done with all this, the output of jit.gen is going to be the visual that I want. And I eventually want to put this on my jit.world window, and I am going to do this by using jit.gl video play. Then I have to give the name of my jit.world context, so gen color, and I'm going to give it the attribute transform underscore reset set to 2. The output matrix goes in here. You can see my window is dark. It's not actually nothing. It is, whoops, there we go. It's not actually nothing. It's showing us the contents of the jitter matrix. But again, right now it is empty. All right, so how are we going to tackle this? Well, let's start by generating that square, because while it's something very simple, it's actually fairly challenging to accomplish this in jit.gen if you are not comfortable with or familiar with certain concepts. So let's see, right now I do not need a second inlet. I believe I will not need a second inlet in my jit.gen patch in this video at all. In any case, what I do need in my jit.gen patch is the object called norm, which is going to give me the normalized coordinates for each cell or each pixel in my incoming jitter matrix. These are going to be normalized coordinates, meaning there are going to be 2 values per cell or 2 values per pixel, a x coordinate and a y coordinate. These are going to go from 0 to 1, 0 being all the way to the left, 1 being all the way to the right, 0 being all the way to the top, 1 being all the way to the bottom. This is going to be the logic with which I determine if a pixel or a cell is inside the inner square or inner rectangle, or if it's outside the inner rectangle, right? Because that is what I want to figure out first. Is my pixel, let's say there is a rectangle of a specific size, is it in there or is it not in there? So how can I do this? How can I figure out if it's in there or not? Well, let's do a bit of drawing to figure this out. So if I bring out my Mighty Pencil, or Mighty Pen, or whatever it is in Adobe Preview, and let's imagine I have this rectangle here, or I want to have this rectangle here, and then I need to ask each pixel, well, are you in there? Because if you are in there, then I need to set your color to, let's say, red, but if you are not, then I need to set your color to black. If you have ever worked with shaders, this is fairly basic stuff. Also, I just realized that what I randomly drew kind of looks like the world map. This has nothing to do with this video, but let's add a little Japan right here. Fantastic. So how can we do this? Well, one way of achieving this can be done by looking at the boundaries, as in we have we have an edge on the left, on the right, top, and bottom. So I can ask each pixel, okay, is your x coordinate larger than this? Is it larger than this? Then it's probably here. And is it lower than this point? Is it between these 2 values? Also, is your y-coordinate more than this and less than this? Is your y-coordinate between these values? If all of these are true, if all 4 of these questions are answered with yes, then it is in the rectangle and it might get, or it is allowed to receive, the color red upon itself. Otherwise, unfortunately, it will be a very sad little pixel because it will not get that red color. So going back into the jit.gen patch, how can we do this? Well, we have the normalized coordinates, so we just have to ask it if it is bigger or larger or smaller than certain arbitrary values. For example, is it larger than 0.25? That's about a quarter into the screen, right? Because we are thinking in terms of normalized coordinates. Also, is it less than 0.75? Now, these are questions we need to ask for the x-axis, right? So I take the norm, which is going to give me x and y coordinates, so I can use Swiss x to single out the x component. Then I can create Swiss y, so I can pull aside the y component, and for now I can do the same thing. I'm doing it like this, so maybe eventually I can give different values. It can be wider or taller than it needs to be if necessary. All right, so these are all questions. These are all going to give me zeros or ones. Now I just need a way to figure out if all of these are 1, or all of these are 0. So I can use the AND object. AND is a logical operator. It works in a very simple way. It will return 1, it will send out 1 if both inlets are non-zero. So if I do this, then if both are correct, if the incoming value is larger than 0.25 and is less than 0.75, I'm going to get 1. If only one is correct, I'm going to get 0. If none are correct, I'm also going to get 0. Now I can do this here as well. And then the result can also be added to this meta AND object. Right, so both larger than and smaller than comparisons are checked together, and then both results are also checked together with the AND operator. And then I can see if a pixel or a cell is within these bounds or not. And to decide what happens next, I can use the ternary operator, right? This is a conditional ternary operator. The first inlet is a question to be answered. It's a 0 or 1, and that's going to be the result of my boundary detection. The second and third inlets are what happens if this is true and what happens if this is false. In this case, I want to pass colors, right? Vec, so I'm determining a 3D vector, 1, 0, 0. So the color red, and then no green, and then no blue. If not, then it's 0, 0, 0. Then it's simply nothing. And then I'm going to send this out. So here is my setup, and here is me clicking the button. Let's see if it works. Yay, we have a red square. Now, if we were actually designing shaders, this would have been a fantastic moment. It might be a bit underwhelming if you do not realize the importance of what we have just done, but this can be our beginning point, right? Because we can, first of all, change the size of the square, and then secondly, we can, instead of passing red and black as colors, we can determine the colors also depending on the position of the mouse. And this brings me to the second part of this tutorial. How do we determine the position of the mouse in this window? Now, jit.world is going to report mouse position from its final outlets if the mouse is being pressed. If I'm clicking the mouse and if I'm holding the mouse, the left mouse button, I do get the coordinates in terms of pixels depending on my screen size. The third value is if the left mouse button is clicked or not. And these are all information I can use, but first of all, I want this to work. I want to receive the mouse information even if I'm not clicking on it. And this is possible to do by, let's see, sending a very specific message to jit.world. And that message is send window idle mouse 1. Sending this message to jit.world is going to make it so when I have my cursor in this jit.world window, I just get the relevant information without having to click anything. Then it says mouse idle and then the relevant information. Okay, so I can use load bank to make sure this message is sent to jit.world each time I load this patch. So I don't need to click this over and over again. And then I can process the results of the detection of the mouse, right? It says mouse idle and then 2 values, meaning I can say route mouse idle, and then whatever comes mouse idle is going to be sent from the first outlets. And of course, I don't need those bunch of zeros there, so I can use zl.slice2, which is going to slice the first 2 elements of an incoming list. And for us, those are the X and Y coordinates of the mouse. Now, this is great. You can see that I'm getting the X coordinates and the Y coordinate, and this is entirely dependent on my screen size. Right now, this goes from 0 to, 350. If I make the window very large, I can go from 0 to 900. Depends on my resolution. But of course, for my jit.gen, I want normalized coordinates. I want these to go from 0 to 1. And a way I can do this is I can get the size or the resolution of my window, and I can divide the mouse position by the resolution, by my screen size in pixels. And how I'm going to do that? Well, I can use getAttr. This is an object that queries object attributes, as in if I, as an argument, give a attribute of another object, in this case, size, the size attribute of my jit.world, it is going to report the size, and when that size updates, as in when I change the size of my window, that value is going to update as well. This is a strange object because to make this work, you actually need to take the second outlet and connect it to the object from which you want to get the data. This looks a bit too much spaghetti for me, so I'm going to make it look a bit nicer, just like this. There we go. And now I should get, each time I change my window size, the resolution of that window, which is something I can use to divide it by, to divide the mouse coordinates by. This is done through, and let me just make this perfect. There we go. This will be done through vexpr. So vexpr is the cousin of expr, which stands for expression, and this vexpr is also going to evaluate a math expression for a list. This is the main difference. It will evaluate a math expression for a list. And here is the syntax. $F1 is the first inlet, the first input. Divide this by $F2. So first thing divided by the second thing, and just apply this to the entire list. So the first element in the first list gets divided by the second element in the first list, and in the second list, no wait, I completely messed that up. The first element in the first list gets divided by the first element in the second list, and the second element in the first list gets divided by the second element in the second list. If you can say that without your tongue getting tied up, you will have understood what that exactly means. But this all essentially means that doing this, let me resize this to make sure, there we go, doing this and resizing the screen to make sure GetAtter reports something is going to make it so the mouse position is normalized between 0 and 2 no matter the size of the screen. It can be full screen, it can be a window, it can be very thin, it can be very wide. It does not matter. I'm always going to get normalized coordinates. This is going to be key moving on to the other generative artworks on this website and on that book that we are going to adapt to Max MSP. All right, so now that we have these mouse coordinates, let's pass it into jit.gen by the way of a parameter. So I'm going back into jit.gen and I'm going to declare a parameter, param mouse pause, and by default, this is going to be a 2D vector, as in it's going to be 2 values. Let's make it 0, 0 by default, so it's on the top left. Why not? Right, and now that I have defined this parameter in jit.gen, I can take this list and I can prepend mouse pause. So now this will turn into a message that starts with mouse pause, and then it will give me the mouse position, and this can go into jit.gen, and now this param object is going to give me those mouse coordinates. All right, now this is cool, but how are we going to make this rectangle size work? Because it's also more tricky than you might realize, because we have to consider each of these sides of the rectangle, each of the sides of our bounding box to figure this out. So let's imagine I'm all the way to the left, right? So my mouse position is at 0. Well, then I want this rectangle to be non-existent, so I want the left edge, the left side, to be at the point 0, right? So not larger than 0.25, but it should be larger than 0.5. I want it to be in the middle. And the right side should also be in the middle. And then the top side should also be in the middle. And then the bottom side should also be in the middle. But as I am going from left to right, as my x coordinate of my cursor goes from 0 to 1, well, the left side should go from 0.5 all the way to 0. The right side of my bounding box should go from 0.5 all the way to 1. The top side should go from 0.5 all the way to 0, and the bottom side should go from 0.5 all the way to 1 once again. So we can simply use a scale object to achieve those very specific ranges of numbers. So my mouse position, I'm going to swizz the x component. We are not worrying about the color right now. And I'm going to scale this. So scale 0 to 1, this is our input. So this goes from 0 to 1, but the output should go from 0.5 to 0. And then another scale, the same thing, the input is from 0 to 1, but the output should be from 0.5 to 1. Okay, and now this is going to determine the values to which we are comparing the normalized coordinates of the pixels. So let's see, the left edge should go from 0.5 to 0. This should also go from the top edge should go from 0.5 to 0 as well. So larger than 0.50 or whatever this value is. And then the right and the bottom edges should go from 0.5 to 1. And that is the lesser than comparison that we are making. Okay, and if this does make sense, when I have it set it up like this, this should work. Now, why isn't it working? Well, it is actually working. This is actually working right now, and I can prove it to you by clicking on this button. And as you can see, the size of the rectangle has indeed changed. But this matrix is only going to be sent when there is a bang coming through here, because then it will be sent to jit.gen, then it's going to get processed, and then it's going to appear through jit.gl video plane in my JIT world window. So I need to send a bang to this JIT matrix constantly, and I can use the second outlet of JIT world for this, which is going to send a bang per frames per second. So on each frame, if it's 60 times per second, 60 times per second, I'm going to receive a bang from this. So it can go here, and now, as I go from left to right, this rectangle is getting larger as well. All the way to the right is covering the entire screen, all the way to the left. It almost doesn't exist. It in fact ceases to exist if I go exactly to the left, all the way to 0. So this part does work, but how do we deal with the color? Going back into the jit.gen patch, the color is right now determined by these two things. If it's in the bounding circle, give it this color. If it's not in the bounding circle, give it that color. And this will work, but we have to make it so that we generate a color based on the y coordinates of our mouse. Now, as I've said, it is the hue that is going to change, right? It is not the brightness or the saturation, or it's not a certain component of an RGB color. So if we are thinking in terms of colors in this artwork that we are adapting into Max MSP, we have to think in terms of hues, saturations, and brightnesses. Huge saturation, brightness, HSL, this is the color system we have to use. Of course, jitter matrices, jitter and jit.gen is going to think in terms of RGB. So we have to use two important objects in jit.gen, HSL to RGB and RGB to HSL. These are going to receive these vectors, they're going to convert it from RGB values to HSL values or vice versa. Now, since I'm going to be thinking in terms of HSL values, the output of whatever I decide upon is going to be an HSL value, hue, saturation, lighting. But I want the final value that is being sent out to be an RGB color, because that is what jitter is looking for. So I'm going to use HSL to RGB right before I send the result into out one and then out of jit.gen to jit.gl video play. Okay, now because I'm doing this, I have to treat these three values as hue, saturation, and lightness. And then I do have to think of certain default values, because if I have 0 lightness, then the color is going to be black, no matter what the hue and saturation is. So the brightness should be 0.5. In both cases, the third value is going to be 0.5. You can immediately see I'm getting this gray color, and I'm getting this gray color because the second color, the second value of my HSL color is 0. So there is 0 saturation, there is only gray. This I can set all the way to 1. And if I do this, now everything is red. Okay, why is everything red? Because I have 1 and 0 as the initial colors of my initial hue of my HSL color, and 1 and 0 are the beginning and ending points. Those are both red. If I put, for example, 0.5 in one of them, well, look at this. Now the background is a nice teal color while the inner rectangle is red. Okay, so then I do know that this hue is supposed to go from 0 to 1. I know that I have the y position, the y coordinates of my mouse position, and I know that the mouse position also goes from 0 to 1. So why don't I just plug the mouse position into the hue of the outer rectangle? What is going to happen? Well, would you look at this? The outer rectangle is switching colors, is going through the color wheel, it's going through the wheel of color, it's going through all possible hues, very much like the P5JS sketch. And as I've said, the inner rectangle does the same thing, but in reverse. So instead of going from 0 to 1, it needs to go from 1 to 0. To make this very easy and intuitive, let's use scale again. Scale, incoming values are from 0 to 1. I want you to convert this into a range of values that go from 1 to 0. And this can be also the result of the y-coordinate. The y-coordinate goes in, 0 to 1 turns from 1 to 0, and that determines the hue of the inner rectangle. And that should be it. There we go. The rectangle does work. The colors do work. It does go from red to red on both sides, and in the middle, it seems to be the same as well. In fact, we can try and do a direct comparison. Right, this is the P5GS sketch. Top to bottom, bottom to top, left to right, left to right, going diagonally from top left to bottom right. And now I can do the same thing in my MaximSP patch. Left to right, up, down diagonally from top left, all the way into bottom right. So here you have it, a recreation of a fairly simple P5GS generative sketch in MaximSP using MaximSP concepts. Now, while this might not look very impressive or very detailed, this can be a starting point, right? The reason I use jit.world and jit.gl video plane instead of just visualizing the jitter matrix in a regular jit.window is to make sure this can be used as a basis for further 3D, OpenGL, JitGL, JitWorld abstractions that you might create or you might use that you have taken from other people. In any case, this is a good opportunity to understand how jit.gen works, how color generation works, how HSL color works, and how mouse position can be applied in a fairly simple way into the workflow of working with jit.world. In the next video, I'm going to, well, tackle on the second sketch as described in the Generative Design book. Until then, thank you for watching.